This is week 6 workshop and we're group 4. Now I've got an example here of a differential equation in Bernoulli's form, which expressed generally is this one here. We've got dy dx plus p of x, y equals q of x, y to the n. Now this is not in linear form. We need it in linear form to solve over here. Because of this y to the n, what we want to do to get it into linear form here is divide both sides by y to the minus n, using the index laws here. So we've got this here, and then since we've already got one y here, y to the 1 minus n, that's expressed like that. So what we want to do to get it in here where we've got a variable here of degree 1 is substitute for y to the 1 minus n. So we'll use v equals y to the 1 minus n. And if we want to express this in terms of v, we can say that y equals v to the 1 over 1 minus n.
We are then given this equation here to solve using the substitution equation y equals v to the power of 1 over 1 minus n for the value of n equals negative 2. For the first step, we'll sub in our n value, which will leave us with v to the power of 1 on 3. The next step down, as y and v are both products of x, we now can differentiate both sides of the equation, which leaves us with dy dx and 1/3 out the front of v to the power of negative 2 on 3 dv dx. From these two equations, we can then substitute our values back into the original equation, which will leave us with 3x with this section here inside here to the power of 2, and then this section here substituted for dy dx down here. And then finally, y to the power of 3, our y value here, substituted in to the power of 3 equals e to the negative x.
I am Midori, so I'm also from group 4, and Jordan already substituted the y equals v to the power 103 on the equation. So now I'm like simplifying it more. So you multiply all the values and then you come to here by these things cancelling out. So it's x dv over dx, and then this one is equal to 1. So it's v and e to the power minus x. So then we divide the whole equation by x to get 1 in front of dv over dx. And then you define 1 over x as px and e to the power minus x over x as qx, because we want to find rx. So rx is x, and then v comes here, and again the rx is x, and our qx is defined here, which is e to the power minus x over x. So this cancel out.
I'm Tom from group 4. In the step previous, we found that ddx of xv equals e to the negative x. So from there we take the integral of both sides, giving us xv equals negative e to the negative x plus c. Therefore v equals negative e to the negative x plus c, all divided by x. From there we find that, knowing that y equals v to the 1/3, that y is going to equal negative e to the negative x plus c, all divided by x, all in brackets, the 1/3. Alright, so just some quick notes. We got when the d is in this form, so y dash plus f of x, y equals g of x, y to the power of n. Our substitution is going to be y equals v to the 1 divided by 1 minus n, and that's going to work for all real numbers.